screen. So we'll continue from where we had left off. We have uh, one last topic pending as part of your RDS, which is your read replica. So in the last session, we looked at how we can have a web app and how we can make use of the RDS database as our backend, and we can store the data basically in this RDS. And then we also discussed about some of the topics like your database backups. So we have two types of backups. We have the automated backups, and then we have the manual backups. So automated backups is the one that is enabled by default, and then you have the manual backup, which is user initiated. So at any point, when you create any backup, we call that as your manual backups. We also discussed about your encryption, so how all the databases supports your encryption. We also discussed about your multi-AZ deployment. So multi-AZ deployment can be used whenever you want to make your database highly available, right? Uh, or rather, it's more for your disaster recovery. So under this, you'll have basically a primary database, and then you'll also have a standby database, which will be like, in the standby mode. So if something goes wrong with the primary database, you can fail over or you can switch over to the standby database, right? So your um, multi-agent is purely for your disaster recovery. It does not improve the performance of your databases in any way. It is only for the disaster recovery. Now, the last thing we have under your RDS is your read replica. Now, at any point, if you want to improve the performance of your database, you can make use of your read replicas for that. So we have two things. One is your performance, and the other is a disaster recovery. So for disaster recovery, we have your multi-agent, and for your performance improvement, we have your read replicas. Now, under read replicas, what happens is you will have your RDS, all right? So your okay. So I'll have one RDS, which will be your primary database, right? Now, what will happen is your application. Okay, so let's say this application will connect to the database. All right, so it will connect to the database and it will fetch the data from the database. So as a user, when we hit this app, whatever the interaction we are doing, it will interact with the database. Now, depending on the users that you have, if you have like lots of users and if all the users are trying to access the application at the same time and they're trying to read the data from the database from the same time, it may impact the performance of the database. So to improve this, we have something known as your read replicas. All right, so your read replica, it is simply a copy of your database. All right, so under this, what you will be doing is you will be distributing. So instead of putting all the queries on the original database, you will run the queries on the read replicas. So this way you're doing a load balancing basically. Unless you're distributing the queries. So the queries will get some of the queries will get executed in this read replica, some of the queries will get executed on this read replica, and then so on. So if you want to improve the performance of your database, we can make use of your read replica. So read replicas allow you to have a read-only copy of your production database. So you cannot write the data to this. You will be writing the data to the primary DB, which gets synchronized with your read replica. So we cannot write the data directly to the read replica. So this is achieved by using asynchronous replication from the primary RDS instance to the read replica. You use read replicas primarily for very read heavy database workload. So if your application is a very read heavy application where you're reading a lot of things, that's where you can make use of your read replicas. So under this, four databases supports your read replicas: MySQL Server, PostgreSQL, MariaDB, and Aurora. So these are the four databases that supports your read replicas. Not all the databases supports it. So this is used for scaling. It does not, you cannot use it for disaster recovery. Must have automatic backups turned on in order to deploy a read replica. You can have up to 5 read replica copies of any database. You can have read replicas of read replicas, but watch out for latency. You can have each read replica will have its own DNS endpoint. Okay, so this will have its own endpoint. This will have its own endpoint. This will have its own endpoint, and then so on. You can have read replicas that have multi-asset. You can create read replicas of multi-AZ source databases. Read replicas can be promoted to their own databases, but this will break the replication. So from this read replica, I can convert this read replica to a database, but the replication will break. All right. So you can have a read replica in another region. So how do you create your read replicas? You can select your database, and if you go to the actions here, you should be able to see read replica. So if you see this one option, create read replica, this is disabled because of the condition that your automatic backups should be enabled. In our case, if you see automatic backup is disabled. If you have enabled automatic backups, you should be able to see this option, which is to create a read replica. Now, basically what this will do is, this will launch one more database for us, but it will be a read-only database. Questions?
So what is that Aurora read replica?
So Aurora is another database that we
Oh,
have. So remember, it supports 6 databases. So we have Amazon Aurora.
oh,
Aurora is Amazon's own database product, basically. So
okay,
you can create a read replica in terms of Aurora.
okay.
Any other questions? Let me know. If not, that's all I have for your RDS. That completes your RDS service. Okay. Give me one moment. All right. The next service that we are going to look at is your DynamoDB. Now, before we look at your DynamoDB, let's understand about your NoSQL database. So, any idea what is NoSQL database or NoSQL database? Any idea?
No, Ravi.
Any guesses? What do you think it could be? When I say
There
no,
won't be any tables, I guess. Like, you said in the relational database, you said there'll be tables structure like, worksheet. So I think it will be different. The format will be different.
Mhm. Yes. So, as the name suggests, yes. So, NoSQL database basically it's your non-structured database. So, with your RDS, if you see, it's a proper structured database, right? So, you have proper rows and columns. But with the NoSQL database, you don't have proper rows and columns. It is not structured properly. So it's a non-relational database. Under this, you will have a database. Within the database, you'll have the table, you'll have the rows, and you'll have the columns. However, it will be not structured properly. So when we talk about your NoSQL database in AWS, DynamoDB is the database that supports your NoSQL database. Other than this, we also have this database called MongoDB, which is a NoSQL database. Now, under this, one important thing to remember is we don't make use of your SQL queries. Unlike your RDS, where we run your SQL commands like select star from table or show tables, show databases. These are all your SQL queries. We don't use any such queries with your NoSQL database. Rather, we make use of your JSON query. So the data, the interaction with the data is done via JSON queries. All right. So talking about your DynamoDB, so DynamoDB is a fast and flexible NoSQL database service for all the application that need consistent single-digit millisecond latency at any scale. So it's a NoSQL database. So at any point, if anyone asks you, what is the NoSQL database in AWS, DynamoDB is what we're talking about. So it's a fully managed database and supports both document and key value data models. Now, what do you understand by fully managed database? Anything?
I mean, AWS is managing everything, and they're supporting both document and
Correct. So, with your RDS, what we did was we went ahead and launched a DB server, and then we started using that to connect with the application, right? So, we were managing that database. Now, with your AWS managed means you don't have to worry about launching a database. AWS will take care of that. All we have to do is just start interacting with that, like create tables, insert the data, and all those things. That's all. That's why it is known as a fully managed database, meaning AWS takes care of most of the parts, like your the servers, the capacity, and all those things will be taken care by AWS itself. So its flexible data model and reliable performance makes it a great fit for mobile, web, gaming, ad tech, IoT, and many other applications. So it has a lot of use cases. Now you can use it in mobile games. You can use it in web applications. You can use it in gaming applications, any ad technology, any IoT applications. Likewise, anywhere you wanna use, you can make use of it. Right. So by default, with your DynamoDB, the data is stored on SSD storage. By default, your data will be stored in three different availability zones. Now, because you have three different availability zones, we have two types of consistency. One is your eventual consistency, which is default. So let's say you add a new data. Now that new data needs to get replicated in all the three availability zones. It does not happen immediately, right? So that's why it's known as eventual. So eventually you will have the consistency across all the availability zones. You also have the strong consistency, but that's not default. You'll have to pay extra money for that. So under strong consistency, AWS will make sure that the consistency is there for all the availability zones immediately. So to work with this, you can go to the DynamoDB service. You can search for DynamoDB. So that's the service you have. And unlike your RDS, where we launch database, here we don't do that. You can straight away start creating a table, and you can start inserting the data into this. You don't have to, like I said, you don't have to create a new database for this. So you can straight away go ahead and create a table, give it a name, and you can give your partition key. Partition key is like your primary key. Okay, so let's say ID will be the primary key. This will be your data type, so binary number string, and this will be your secondary key, sort key. Now, if you don't want to pay any cost, you can go with the default settings, which is this you get. If you're ready to pay some cost, you can go with the customized settings. So we will be going with the default settings, and then click on create table, and this will create a table for us. Okay, so here my table is created. Now, once you click on this table, you can start inserting the data into this. So this items summary that you see, in that's where it will show you like how many items you have. But if you click on this one, explore a table items, if you go to that, so here as of now you can see we don't have any items. So you can start adding items to this. So here you can see create item. So this will be your primary key. So this will be as it is. And then you can start adding more columns to this. So let's say string and something like, let's say name, and let's say we will give the value to this. Then let's say number, and let's say contact, and let's say we will give the contact information and create a item. Now, unlike your RDS, right, we don't have a fixed column names, right? Only this primary key is fixed, but the rest of the things is unstructured. Now, let's say if I create one more item, this is constant because that's my primary key. Now I can add a different item altogether. So let's say location, and create item. Now, if you see here, my data is not structured properly. That is simply your NoSQL database. Questions until here? So unlike your RDS, where this column names that you have, it is applicable to all the items. But with the NoSQL, you can do it the way you want it. So in this case, my location is applicable only to this ID. Likewise, my contact and name is applicable only to this ID. That's your non-structured data. So eventual consistency reads, consistency across all copies of data is usually reached within a second. So like I said, that you will see a latency, but it will hardly, you will notice it. Repeating a read after a short time should return the updated data and give the best performance ever. And then you have the strong consistent reads. A strongly consistent read returns a result that reflects all writes that receive the successful response prior to the read. So here immediately you will see the updates. Now coming to the cost, you will have this provision throughput capacity, and we have this write capacity where you will be charged $0.0065 per hour for every 10 units, and then the write read capacity, which is $0.0065 per hour for every 50 units. And then you'll also have a storage cost of $0.25 per GB per month. All right. So the main difference that you will find between your DynamoDB and RDS is obviously your RDS is SQL database and DynamoDB is a NoSQL database. The other main difference you will see is that your DynamoDB offers a push button scaling. So unlike your RDS, okay, let's say you launched an RDS instance, and if you want to change the instance type of this, you will need to stop the DB and then change this. So there is a downtime associated with your database. But with your DynamoDB, you can do it on the fly, right? So it gives you a push button scaling. All right. So if I go back to the table under actions, I can update my settings. All right. So over here, let me see, where is that? Yeah. So this one, if you see this read capacity and write capacity, by default you will get 5 read capacity and 5 write capacity under the free tab. Now, if you want to increase that, you can do it. So it's a push button scaling. So I can specify what is my read capacity and what is my write capacity. So right, so here you can give a range as well. If you don't want to give a range, you can simply give the number and just click on save changes, and it will update the DynamoDB. There's no downtime associated with it. That's another difference here. So DynamoDB offers push button scaling, meaning that you can scale your database on the fly without any downtime. RDS is not so easy, and you usually have to use a bigger instance size or add a read replica. Questions?
No, no, Raghav.
Now, if you're working programmatically with this, your query may look something like this. Not this one. Okay, so here if you see, we are doing this put underscore item. So this is same as insert into table, and then what data you want to insert. So you can see this is a JSON blob, right? It's a JSON data. This is how we interact with your DynamoDB. So put item and then the item, that's your column name basically, and the value that you want. That's all I have as part of your DynamoDB. If it's any questions, let me know.
No, Ravi.
Okay. The next database that we are going to look at is your Elasticache. Okay, Redshift. We'll look at your Redshift. Now, earlier, so I think a year ago or so, Redshift was part of your database service. Okay, so under here, if I go to database, so earlier, your Redshift uh, was part of the database service, but now they have moved it to analytics. So here you should be able to see the Redshift service because this is mainly a data analysis service. So you can use it. This also acts as a database, but mainly we use it in your data analysis or data engineering side, right? So can you tell me what any idea as to what is data warehousing? Any idea? Okay. Tell me what is a warehouse?
Warehouse is the place where we store something. Okay.
Right.
Generally.
So generally, warehouse is something that can be used to keep a lot of items, right? Any items we can like basically it's a huge storage option for us where you can stack our items, right? The same way when we talk about your data warehouse is also basically a warehouse. It's a storage place where we can dump all kind of data for us, and it's generally a huge amount of data that we have. So generally, when we talk about your data warehousing, so we have different tools. So you have Amazon Redshift, Snowflake, BigQuery, Teradata, Apache Hive, Azure, IBM DB2. All these are your databases that can be used for your data warehousing. So that's where I told you data warehousing is mainly used when we talk about your data analysis. So what we can do with this data warehousing is any kind of data you want, you can dump into this data warehouse, and then you can start using that to kind of generate different reports. For example, let's say you have a product, you're selling that product across the globe, different locations, different regions. Now imagine the amount of data that gets generated. So one is something like, let's say your manufacturing cost, you have the selling cost, then based on the location you have the currencies exchange, you have the tax, different tax. So there are so many data that gets generated. Now what we do is we take all of this data, right? We dump it into one place and we start running queries on them to generate a report as to how well the performance has been for the company. So how many products we have sold, what is the profit, in which country how much of products we sold. We can generate all those kind of reports by making use of a data warehousing. So in AWS, when we talk about your data warehousing, Redshift is a service that we have. Questions until here? All right.
No.
So Amazon Redshift is a fast and powerful, fully managed. So again, this is AWS manages this completely. Petabyte scale data warehouse service in the cloud. Customers can start small for just $0.25 per hour with no commitments or upfront costs, and scale to a petabyte or more for $1,000 per terabyte per year, less than a tenth of cost of most other data warehousing solutions. So basically, AWS is telling this is super cheap when compared to the other options, and performance-wise also, this gives you a very good performance. Now, generally, when we talk about your databases, they can be categorized into two types. Okay, so one is your OLAP and the other is your OLTP. Now, OLAP it stands for Online Analytics Processing, and OLTP stands for Online Transaction Processing. So analytics processing is where we basically run analytical queries. This is where your Redshift falls. Transaction processing is where you can process your transactions. For example, bank transactions, or you're buying something. That's a transaction. All those goes into your RDS databases. So OLAP transaction example is a Redshift. So let's say, for example, okay, you need to calculate the net profit for EMEA region and the Pacific region for the digital radio product. So let's say you have a product, digital radio product. Now you have been asked to calculate the profit in the EMEA region and the Pacific region. Now what happens is this will pull in a large number of records, something like the sum of radios sold in the EMEA region, sum of radios sold in the Pacific region, the unit cost of each radio in each region, the sales price of each radio, sales price minus unit cost. So all these data gets generated. Now using these data, I can get this. So I'm basically doing an analysis. That's where we can utilize your Redshift. So data warehousing databases use different type of architecture, both from the database perspective and the infrastructure layer. So the way your data is stored in the data warehouse is very different when compared to your RDS. So under this, you have two options. You can go with a single node. You can have only one server, which can give you up to 160 GB of storage capacity. Or you can go with multi-node, where you'll have the leader node and you'll have the compute node. So basically, you'll have like a master-slave architecture. Sorry. So leader node who manages client connections and receives the queries. So the leader node is responsible for managing all the connections and getting the queries from the application. And then you have the compute nodes that stores the data and performs the queries and computations, and you can have up to 128 compute nodes. So compute nodes are the one that actually does the work for us, and we can have up to 128 compute nodes. So here, if you go to the Redshift service, if you search for the Redshift service, this is what we have. You can get started with this. I won't be showing an example for this because it is chargeable. However, if you're interested, you have the serverless option as well. So here you can go with your clusters, right? So you can click on create cluster and you can start filling in the details. You can give a name, choose the size of the cluster. You can choose your node type, how many nodes you want, one, two. You can load some data, sample data, your username, password, your network, all these details you can fill in. Then click on create cluster, and this will launch two databases for us, or rather two node for us of this capacity. You can obviously choose what you want, all right? But in this case, if you see T2 is not available, so it's chargeable. You'll have to basically pay money for this. Okay. Uh, Now, talking about your storage, how your data gets stored. So, unlike your RDS, with your RDS, what happens is your data gets stored in the row format. Okay, so you can correlate this to the Excel that we saw in the other session. So you'll have the data in the row format. So you'll have the column names, and then in the row format, you will have the data, right? So this will be your row format. So your data will be stored like this. Okay. Now in your Redshift, your data is stored in the columnar format. So instead of storing the data as a series of rows, Amazon Redshift organizes the data by column. Okay. So in your Redshift, the data will be stored like this, in the column format. Right? So unlike row-based systems, which are ideal for transaction processing, column-based often involve aggregates performed over large data sets. And since only the columns are involved in the queries are processed, and columnar data is stored sequentially on the storage media, column-based systems require far fewer input outputs, greatly improving the query performance. So it is believed that if you're storing the data in the column format, the query performance will be much better and it will be much faster. So the availability, it is currently available in only one availability zone. However, you can create snapshots and you can restore that snapshots in a different availability zone in the event of an outage. Questions, Anna?
Yeah, one question. So, like it said, the Redshift serverless, right? So, what is that serverless? Is it like platform as service or software as service? Is it because of that it is saying as serverless?
Okay, so serverless would mean, so in this case, if you see, we are managing the capacity, right? The CPU, how much CPU you want, how much RAM you want, we are defining it. So this is server approach.
Okay.
Serverless would be, we are not going to worry about any of those things. So nowhere you will find the server related information as to how much CPU you want, how much of RAM you want. Only you, the even the storage capacity, it's not there. All those things will be managed by AWS. So this is a serverless approach.
Okay.
So all of those things are, so for example, DynamoDB is a serverless approach.
Okay.
RDS is a server approach where we have to define how much of CPU we want, how much of RAM we want, how much of storage we want.
Okay.
That's a server approach.
Got it.
Now, because we are dealing with huge amount of data, to easy manage the storage capacity, we also have this advanced compression. So columnar data stores can be compressed much more than the row-based data stores because similar data is stored sequentially on disk. Amazon Redshift employs multiple compression techniques and can often achieve significant compression relative to traditional data stores. In addition, Amazon Redshift does not require indexes or materialized views and so uses less space than the traditional database system. So, unlike your RDS, where we have indexes like primary index, secondary index, we have different views, which in turn occupies us more storage. Your Redshift does not have any of those things, so automatically the storage capacity utilized is much lesser. Also, when loading the data into an empty table, Amazon Redshift automatically samples your data and selects the most appropriate compression scheme. So, Amazon AWS is intelligent enough. Okay, so based on the data that you're loading, it will automatically sample your data and it will suggest you the best compression technique or the scheme that you can use to compress the data, right? And then you have this massively parallel processing. Now again, because we are dealing with huge amount of data to have a good performance, to improve the performance of your database, we have this massively parallel processing feature where Amazon Redshift automatically distributes the data and query load across all the nodes. So if you have like, let's say 10 node cluster, the query and the data will get distributed between all these nodes. So your processing will be in parallel. So Amazon Redshift makes it easy to add nodes to data warehouse and enables you to maintain fast query performance as your data warehouse grows. Questions? Okay, coming to the
No,
cost.
sir.
Yeah, sorry.
No, no questions.
Okay. Now coming to the cost, you will have to pay for the compute node hours. So basically the duration your nodes are going to run. Okay, so number of hours. So total number of hours you run across all your compute nodes for the billing period. You are billed for 1 unit per node per hour. So if you have a 3 node data warehouse cluster running persistently for an entire month, that would incur 2160 instance hours. So your cost will be calculated on that hours. Now you don't get charged for the leader node, you're only going to charge for the compute nodes. Right? So if you have a leader node and lots of compute nodes, you're only going to pay for the compute nodes. From the security perspective, you can make use of your SSL for transition, data in transit. For data at rest, you can use AES 256-bit encryption. And again, by default, Redshift takes care of the key management. You can also manage your own keys if you want, and we can make use of the KMS, key management service, for generating the encryption keys. That's about your Redshift. This is mainly from your certification. In case you're interested for certification, you will need to know this. If not, from the interview perspective, you don't have to worry about this. Any questions? Let me know. If not, then we'll move on to the next topic.
No.
Okay. The next database that we are going to talk about is your Elastic Cache. Now, as the name suggests, this is a cache database, which is again used to improve the performance of your database. So under this, what happens is you will be having a cache database that will be run. So you will have an Elastic Cache database that you will be running. So it's simply a cache, right? So Elastic Cache is a web service that makes it easy to deploy, operate, and scale an in-memory cache in the cloud. So the service improves the performance of your web application. So generally, if you're having web applications, mostly you will utilize a cache database. So this helps you to improve the performance of your web applications by allowing you to retrieve information from fast, managed, in-memory caches instead of relying entirely on your slower disk-based databases. So again, instead of depending on the original database, we can make use of your cache database. So Amazon Elastic Cache can be used to significantly improve latency and throughput for many read-heavy application workloads, such as social networking, gaming, media sharing, Q&A portals, or compute-intensive workloads such as a recommendation engine. So you can use anywhere you want. So the caching, it mainly improves the application performance by storing critical pieces of data in memory for low latency access. Cached information may include the results of output intensive database queries or the results of computationally intensive calculations. So you have very intensive calculation that you want to do. You can do that and you can store the results of that in the cache database so that whenever you want the results, you can simply get it from the cache database instead of running that calculation again and again and again, which is putting the load on the database. So under this, you'll have two options. You will have the memcached and you have the Redis. So Redis is a very popular cache database that we have. So memcached is a widely adopted memory object caching system. Elastic Cache is protocol compliant with memcached. So popular tools that you use today with existing memcached environments will work seamlessly with the service. So when you can search for the Elastic Cache service. So here, and you can choose between memcached and Redis. So here you can click on get started, and you can again here you'll be creating a cluster. So create cluster, and you can choose whether you want to create a Redis cluster or you want to create a memcached cluster. So Redis is again a popular open source in-memory key value store that supports data structures such as sorted sets and lists. Elastic Cache supports master-slave replication with multi-AZ, which can be used to achieve cross-availability zone redundancy. So you can choose which one you want. So let's say Redis, and you start filling in the details. You want this for demo purpose, for devotees, for production. You can give your name, give your network information. You can, these are the options you're getting: the port number, then cluster mode, auto failover, encryption, all these things. And then when you click on create, this will start creating your Redis cache database. Again, this is mainly from the certification perspective. We won't be looking at an example for this, and uh, you don't have to expect any interview questions from this. Questions?
No, sir.
No.
Okay. Now, the last thing we're going to talk about is your Aurora. So Aurora is again a SQL database that you have, which is part of your RDS. Just want to talk a bit more about this. Once again, Amazon Aurora is AWS its own database product. All right. So Amazon Aurora is a MySQL compatible relational database engine that combines the speed and availability of high-end commercial databases with the simplicity and cost effectiveness of open source databases. So Amazon Aurora provides up to 5 times better performance than MySQL at a price point 1/10 that of a commercial database while delivering similar performance and availability. So in terms of cost, in terms of performance, Amazon is telling you that Aurora is much, much better when compared to the other databases. So one of the feature you have under this is your auto scaling. So you can start with 10 GB and you can scale up in 10 GB increments and you can go up to 64 terabytes. And your compute resources, you can scale up to 32 CPU cores and 244 GB of RAM capacity. So here, when you go to the databases, you can choose where, if you want to create the Aurora database, so whether you want to go with the MySQL or the Postgres, you have two options over here. All right. So under this, you will get 2 copies of your data in each availability zone with a minimum of 3 availability. So unlike your other databases, where you'll have only 1 copy of data in one availability zone, with Aurora, you will have 2 copies of the data in each availability zone, and you will have a minimum of 3 availability zones. So that means at any point, you will have 6 copies of your data. That way, your Aurora is capable to handle the loss of up to 2 copies of data without affecting the database write availability, and up to 3 copies of data without affecting the read availability. So it's very highly available, right? It also has this self-healing feature. So data blocks and disks are continuously scanned for errors and repaired automatically. So it will look for any data blocks, it will look for any disks, and if there are any errors, it will automatically fix those for us. So under this, you generally when we talk about the replicas, you have 2 types. So Aurora can support up to 15 read replicas, and MySQL supports only up to 5 read replicas. That's about your Aurora database. Let me know if any questions.
No.
All right, that completes your databases. I would suggest you to concentrate more on the RDS and then on the DynamoDB from the interview perspective. Other than this, the Redshift and Elasticache are mainly from your interview perspective. Okay, that's all for today. I don't want to cover new topics. So in the next session, we will be starting off with your messaging services. So SQS, SNS, we will be talking about those in the next session. So next session will be on Monday, right? So I will see you guys on Monday. All right.
Okay, Ravi. Thank you.
Thanks everyone. I'll see
Thank
you.
you, sir.
Bye bye.
Bye.